Hello, everybody. I'm Lara McLaughlin, and I'm going to be presenting my arc length project. So for my path, I chose to map the two warm-up laps that we run at track practice every day before we do anything else, including drills and other workouts. Because we sit at the far end of the field on the bleachers across from BCA, that's where we meet before practice starts to discuss things. We don't start running our two laps until about the green dot that's located on the picture on the left. We run our two laps, and because we do drills at the red dot um, on located on the picture on the left, we have to run an extra 100 meters or an extra curve to get there to do our drills. So, knowing that I should run about 900 meters or 2,952.76 feet, can I use the arc length formula myself to aid me in calculating the total distance of our warm-up um, myself? So how will I actually calculate this? Well, running the 2 1/4 laps from the point, the green point on the picture from the previous slide, I would have to run 4 straightaways, which are the green sections, and 5 curves, which are the red sections on the picture on the left. And for this, we're going to assume that I'm running in lane one the entire time to just keep my distance consistent. Um, so for one straightaway, all I did was go on the Google Maps, uh, where everyone else's paths are, and I used the measuring tool to measure out the straightaway, and it was about 330 feet. And then for one curve is where we are going to make a parabola and use the arc length formula to calculate uh, the length of one curve. So in terms of actually calculating the curve, I tried my best to find the point at which the curve really becomes the straightaway and vice versa. And so I came up with the following points. I measured the distance across the curve, which was 208 feet, which I made my x-axis, and therefore the 2 points um, across from each other would be -1040 and 140, and those were my zeros. And then I made uh, the vertex of the parabola, which is the highest point of the curve, to be on the y-axis just to make it easier, and I found it to be 93 feet from the origin, so therefore the vertex's point is 0, 93. And then using these points, we can find a regression equation. The way I found the regression equation was by plotting the points into Google Sheets and making a scatter plot, putting a trend line that was polynomial, and then it gave me a regression equation. So the regression equation it gave out was -0.0086 times x squared plus 93. And then using the regression equation, we can find its derivative to use in the arc length formula, and that was -0.0172 times x. Now, actually using the arc length formula is located at the top of my work, and all I had to do was plug in the derivative of our regression equation and also set a and b as -104 and 104 as our bounds, and plugging all that in and putting that in the calculator spit out 291.33 feet for one curve. So now actually calculating the total length of these warm-up laps, again, as I mentioned previously, it would entail uh, 4 straightaways and 5 curves added together. A straightaway, as a reminder, was 330 feet, and the curve that we just calculated is 291.33 feet. So by uh, multiplying 4 straightaways uh, and then adding 5 curves together, we get a total of 2,776.64 feet. The actual length, as I said in the beginning, was 2,952.76 feet. I would say that this is a relatively close calculation. It was a 6% error or a 6% difference between the two. And I would say that would be due to the fact that I had a hard time telling where the curves and straightaways diverged. But overall, a 6% error isn't too bad. Um, and yeah, thank you for listening to my arc length presentation.